Sorry, welcome to today's webinar on the rise of AI agents. Today we'll be diving into the rise of the change in the redefinition of automation and intelligence that we are seeing becoming more popular in the AI space. So today we are also diving into the most exciting advancement in recent AI, which is the AI agent information, but they think, they plan, they act, and they also learn to automate complex tasks and enhance productivity. So as AI is rapidly reshaping industries, understanding how these agents work, their benefits, the challenges, and future impact is very crucial. So in this section, we will explore how AI agents are redefining automation and intelligence, unlocking new possibilities for businesses and individuals. To our presenter today in the person of Benjamin, he's going to walk us through AI and AI agents. And I want to guarantee you that this is going to be a very much valued packed section. So just stay tuned, and if you have your notepad, please get your writing materials. You have a lot to learn. So Benjamin, are you with us?
Yeah, I am here.
Hello, Benjamin.
Yeah, can you hear me? I'm here.
Okay, so the mic is, yeah, the mic is over to you.
Okay, yeah, thank you very much, Mecca, and good evening, everyone. Good morning, good afternoon from wherever you're joining us today. So I'm glad to have you all, everyone here. I see a lot of names here, can't call everyone, but is it's good to have you all here today. And so today we'll be talking about AI agents, starting from the end of last year towards November, December, there's been this hype and buzz about AI agents and all. So today we'll be diving into that. Of course, we know one section is not enough to do justice to that topic, but then we'll be trying our best to see what we can do today. Okay, so meanwhile, if you have your questions, do well to keep it. And at the end, we will take questions and contributions or discussions whatsoever. Okay, so thank you all once again for joining today. All right, so the rise of AI agents, redefining automation and intelligence. Okay. So I don't know, can you see my screen? So I'm sure.
Yes, we can still see your screen.
Okay. All right, so there's been this buzz about what AI agents can do, and they can move mountains and everything. I know Damar Shah, the co-founder of HubSpot, he said agents are the new apps. Like the way we have App Store or the iOS or Google Play Store, where we download the apps, it's the same way we are going to soon be downloading agents on maybe Agent Store, whatever the name would be then, you know. And then Mark Zuckerberg from Meta said there would be probably more AI agents than there are people in the world. That's to tell you. And further on this talk, he was saying something like the same way we have each business have a social media account to handle today. That's the same way each business or persons are going to have individual agents, in coming in the future, you know. So, and then NVIDIA CEO Jensen said there's going to be, for the very first time, agents sitting on top of tools. And you know what that means? It's more like AI being on steroids. You have a lot of tools to do a lot of things, and then you have agents interacting with all of these things. And then Satya from Microsoft said AI agents will become the primary way we interact with computers in the future. A lot is really changing and everybody's giving their opinion. Of course, I would expect this because there's going to be a paradigm shift from the things we know to be technology to what it will be in the future. Now, I'm going to play a couple of videos. So can we, yeah,
We can, if the video has an audio, I can hear that. Hello, we can't hear you. I don't know if this video has an audio, but we can't hear what
no,
is
I'm actually
saying.
not talking. I'm just wanting you guys to see the video, what is playing there, right? So
Okay, very
yeah,
well.
this is the second one shortly before we continue.
Hey R2X, how are you?
I'm doing great. Thanks for asking.
What can you do for me on my PC?
I can help you with application usage, analyze and summarize documents, and assist with tasks during your Microsoft Teams meetings.
How do I use generative AI to replace the jacket in this photo?
In Photoshop, use the generative fill feature. First, select the jacket with the selection tool. Then, click on Generative Fill in the contextual taskbar. Describe the replacement you'd like, and Photoshop will generate options for you.
Could I share an insurance policy with you?
Sure, please go ahead and share it. I've got the insurance policy open. How can I assist you with it?
Great. I had some snow melt on my roof that caused a leak. Does my insurance policy cover that?
Your policy includes coverage for.
Okay, for our time, let's just go on. So let me just briefly explain what happened in the two videos. Can you guys hear me?
We can hear you, please.
Okay, so on the first video, if you notice what happened, I don't know if you guys got the audio. So you simply give a command to the agent and say, okay, buy me milk from Instacart, right? That's the only instruction. It's more like you sending somebody or sending someone on an errand and say, go get me something from the nearest supermarket, right? So this agent goes to Instacart or wherever e-commerce site you ask it to, it searches through the catalog for the products and then maybe looks for the best. For example, if you say look for the one between the range of maybe $1 to $2 or $3 or something like that, then it's going to look for that product range and it's going to pay for that product, um, place the order, and then it's going to be delivered to you in your house without you doing anything. Right. And on the second instance, like a software engineer is asking the agent to clone a GitHub repository, and that's just all. And it does everything for you without any human interference. That's what agent is. Then on the second video, I don't know if you guys heard the conversation between the guy and the agent. That's actually by NVIDIA. The first one is OmniParser by Microsoft. They released it, I think, this week. Then the other one, the second one I played was from NVIDIA. So you have like your Photoshop. Let's say a newbie who doesn't even know anything about Photoshop just kind of access the agent to say, okay, hey, how can I crop this photo and change this jacket? And you're going to see, you're going to get a guide telling you, okay, do this, do that, do that. Someone like me who doesn't even know anything about graphics, I could actually use that to do an entire work without having to ask anybody to help me. So that is what agents are coming to do. That is what agents are coming to do. So they are coming to make tasks easier for us without any human interference, without us having to do anything on our own. Are we with me, please? So I know I'm not talking to myself.
Yeah, we are with you. Please go ahead.
All right. So I know you might be asking, so what's the AI agent? I know I've just been giving the high level, the abstract level, what the agents can do. So an AI agent is a system designed to reason through complex problems, right? Create actionable plans and execute these plans using suite of tools. Now, before I go forward, most of us have actually used one or two agents without even knowing it. Yes, we have. They're already in existence, but actually in a low key without us knowing that these are agents. So anything that can actually create actionable plans, execute these plans using a couple of tools, right? It's an agent. And it follows a continuous cycle, more like a loop of thinking, planning, acting, and reflecting. Okay? So now let's go through this continuous cycle of AI agents, all right? So first of all, an AI agent is meant to think. More like your mom, for example, is going to ask you, hey, go get me, let's use the example of getting a milk from the nearest supermarket, right? You're going to think, what is your mom asking you to do? She's asking you to go get milk and not petrol, to go get milk and not maybe dishwasher or something. So you first of all think and
Hello, are you
understand.
still here?
Yeah, can you hear me?
Hello, Benjamin.
Can you hear me?
Hello, Benjamin.
Yeah, hello.
Hello, sir. We can hear you, sir.
Can you hear me?
Yes, sir.
Okay, I don't know, maybe. So first of all, the agent is meant to think and understand. So it listens to what you say, what you're asking, then processes available data. So I always want to liken this to our own, because everything we kind of program the idea is gotten from our physical world, right? You're asked to carry out an errand. You need to first of all understand what the person wants you to do. And you need to think, okay, have I done this before? Have I gone to this supermarket before? What was the road I took? Now that is the planning stage of it, right? After you understand what the person is asking you to do, after the agent understands rather, what you're asking it to do, maybe through voice or through chat or whatsoever, then it plans, it decides on a strategy to achieve a goal or answer the question that has been asked. Are you guys with me, please?
Yes.
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 So after the planning stage, then the agent acts, right? So of course, after saying, okay, this is the best way to go to the supermarket, or this is the best place to get the milk for maybe $5, $2 or something like that, then it executes the strategy. So e.g. calling an API or going to a website, clicking a button, retrieve data, user interaction, or whatsoever. All right. So, and then the last part of it is reflecting. So it assesses this information, its actions, refines and improves performance. Now, the reason for this last action, which is the reflect, we learn over time. Sometimes if you drive over a certain, you apply certain route over and over again, you will know that, okay, sometimes at so and so time of the day, there's usually traffic here, maybe from 4 p.m. to 6 p.m. or something like that. You know that, okay, you're meant to avoid that road towards evening. So you reflect, and over time, you learn that I can't take this road at this point in time. You understand? So AI agents are meant to reflect and assess their action. You know the way you give this thumbs up if ChatGPT gives you an answer and say, okay, the answer was right or it was wrong, it helps you to learn and improve over time. Are we following, please?
Yes.
All right. I just want to be sure I'm carrying you guys along. All right. So this is just a simple overview. I won't go into the details, but I just wanted to kind of put all of this into perspective to tell you, okay, although I'll still explain some of these other concepts. So it goes through a cycle, it's a loop. It thinks, it plans, it acts, and it reflects, and it goes through the same cycle again. So for it to think, of course, it has to make use of LLMs, large language models, to understand the text or the audio, or whatever it is you're giving to it, to say, okay, do this, do that, okay? And then for it to reflect, it has to monitor its accuracy, compliance, fairness, and relevance. Okay, that's what it means to reflect. It needs to learn on its own. And of course, for it to act, it needs to make use of other agents or other API or whatever. So let me give an example. When I say most of us have actually used some agents, we all use ChatGPT today for several things. I'm going to use an example of me being a techie guy. I use ChatGPT or maybe DeepSeek, the trending one now, but I've always used Copilot and ChatGPT for my work, for software, to debug and to make my work faster, of course, to become 10x faster. So now, if I give this guy a tag to say, define a function for me, okay. So if I give ChatGPT a tag to say, okay, I want you to write a function that does maybe to, sorry, I'm getting something on my screen. Give me a second. Okay, sorry about that. I got a message on the screen. Are we together, please? All right. So now what ChatGPT does, it doesn't just spit out response and say, this is the function. It actually passes that code through an interpreter, a compiler, first of all. If you ask, for example, to do analysis, right? Maybe you're a data analyst or something, and you ask it to maybe draw a chart or do an analysis for you, it actually does that under the hood before giving you a response. And that's why if you're using a free version of ChatGPT, after some time, they will tell you you've exhausted your quota. You can't do analysis for today. See, maybe 3, 5, or 6 hours later before you can do another analysis. Have we seen that before? Are we together, please? Hello?
Yes, sir. Yes, sir.
Okay, so that simply telling you it's actually calling an API. It's not just spitting an answer to say, okay, 1 + 1 is 2. If you're asking it to do a calculation, it does that calculation for you. Yes, it does. Okay, so that's just this, and I'm going to explain other concepts like these other guides here and these other ones later. Okay, so let's just go on. So how AI agents work. All right, so AI agents integrate large language models to power their reasoning, comprehension, and decision making. So wherever you say there's actually an engine under there that understands. It's more like someone speaking Chinese to me. I don't actually understand what the person is saying. For me to understand, there has to be a middleman to interpret and say, this is what this guy is saying. So that's what the LLM is meant to play. It's meant to power the reasoning, the comprehension, and decision-making abilities of the agents. All right? So the typical workflow of an AI agent. So first of all, there's an input, right? You ask a question or give a command, do this. Then the agent has to reason. We've actually talked about it. It has to think. So the AI agent interprets the request and formulates a plan using a reasoning loop. That's what we discussed previously. Then next, it processes. The agent makes calls to Gen AI APIs or enterprise data. Of course, there's always a data. These models or these systems are being trained on terabytes of data. So it has to go through that data to gather more information. Then next, it plans. The agent processes the gathered data and formulates a response or an action. Then before it takes the action, okay, executes that. I've already explained that previously. Then it learns at the end. So this is like the workflow that the agent goes through every command you give to it, okay? So next, I know some might want to ask, what's the role of LLMs in AI agents? All right. So first of all, LLMs, large language models, are the brains of AI agents. They provide the reasoning comprehension, the reasoning comprehension and language generation abilities that agents require. So these LLMs can be either open, like publicly available models, or open source alternatives like DeepSeek or ChatGPT. It could be small, that's optimized versions that run efficiently on local hardware, all right? And also, it can be trained or tuned anywhere. It could be on premises, it could be cloud, it could be just about anywhere. So there are different forms of LLMs we can actually use. I guess those who are more techie or developers can understand much of this, all right? So next, now what AI agents actually look like? Now, what most of us see is this guy here, the interface. Nobody cares what happens, just like we drive our cars. No, except you're a very curious person. You don't care what happens when you turn your ignition, what happens in the combustion, what happens, how does the piston heat, and how does your fuel get. Nobody cares about that. You just want to turn on your ignition and step on the gas pedal and you get to where you're going. So everything you're concerned is the interface, right? How you interact with the AI. It could be a chat window, it could be a voice assistant, it could be a website, it could be a button, just about anything. All right, then we have the workflow, that's the engine. So behind the scenes, the agent flow follows a series of steps or nodes in a flow chart, right? Do this if this is true, otherwise do this, or stop here if this is this. All right, so assessing information from a database, making decisions based on what it finds, and performing tasks like sending an email, it could be just anything. Are we together, please?
Yes, sir.
All right, thank you. Just want to be sure I'm carrying you guys along. So like I said, if you have your questions, please just keep it at the end and I'll be glad to answer them. All right, so AI agents in action. All right, what are the places where AI agents can be applied? What are the places it's already being used or it has potential to be used? All right, AI agents are already transforming various industries, even as we speak. It's not something in the future, like say by next year, 26, or maybe by December or third quarter, it's already in use. All right. So in software development, I had to put this first because I mean, that's like my expertise. So AI agents are already transforming software development. You know, one of the examples is you using, I don't know who else might have used Replit's agent before.
I've used it before.
Yeah. So you see, even someone who, let me give an example, say my dad, who is not even tech inclined, can just say, okay, Replit, I want you to build, okay, calculator app is very basic. I want you to build a tax manager or a to-do app for me and deploy it on Firebase or deploy it on Vessel or deploy it on whichever platform, right? And of course, you already have your credit card and you've already integrated most of those, maybe by toggling a button and all of that. And Replit agent does that for you without you knowing how to program. Of course, it shows you all of that on your screen, writing the function, doing the test for you, maybe packaging the module and deploying without you knowing anything about software development. Am I right? That's what agents are meant to do. There are a lot of them. We have a lot of them embedded in our IDs, embedded in many places. Okay, so I'm just giving an example of software development, how agents are already transforming that. We have that of healthcare, we have in finance, we have in retail and e-commerce. I think I've seen that of retail and e-commerce too, a practical one whereby AI agents place calls for you. It takes care of your your okay, like the one we saw, the video I played right before we started, whereby you just say, okay, I want you to get milk from Instacart. And that's just all. Your credit card is already there. And then it goes there, buys the milk, places the order for you, and all you say is your milk be delivered to you. And then customer service. I've seen companies who use this AI agent that helps them to place call, right? Say you have a database of like 50 customers and you want to reach out to them over the weekend and ask them certain questions. So this agent does the call for you without you having to sit down and maybe place those boring calls. Yes, sometimes boring. All right. So, all right. So what are the benefits of AI agents? There are a lot of benefits, but I think let's just go with the 6. So one of them is efficiency. Helps to automate repetitive tasks and freeing up human resources. Imagine me having an agent that will have to call like 200 of my customers. I say this because I've been in a shoe where I had to call customers because as a technical guy who worked on the project as a back-end engineer, I needed to understand something. Previously, the customer support was always calling, but at some point, I felt I needed to talk to the customers myself and understand what are the problems. Is it that, okay, I built this stuff too technical? I just want to get your perspective. Can you tell me? I know that's not something normally I should be doing, but I just wanted to get from the customers directly. And I had to do many calls. That was not something I used to do. But talking to the customers directly, I understood their point of view, different from what I always want to sit down in front of my screen and tap away my time. So, but having an agent do that call for me and understanding the technical details and getting the customers talk to it saves me a lot of time. So secondly, accuracy reduces human error. We know that. Third, we have scalability, right? So handle growing demands without needing additional personnel at all. The same agent that calls one person, of course, the same time can call 200 other persons. Yes, it doesn't have to end one call before calling the next person. It doesn't. It does that simultaneously, all right, at the same time. So number 4, personalization. It adapts to user preferences for better experience. Number 5, 24/7 availability. It's always there around the clock. You don't say this agent have to sleep and wake up or maybe take some time. Sometimes if you're calling customer care, they will tell you to hold on for some time, maybe because a lot of people, but AI agents will be there round the clock. And last on the list here, cost savings. This is what the company cares more. Because at the end of the day, if I have to pay like 5 customer service personnel and paying them like, say, $600 per month, for example, I can get one agent and then pay that agent and then subscribe or wherever, if it is maybe in-house or whichever way, as cheap as $50, for example, for a month. And I'm just using one agent rather than using 6 agents and paying each of them like $600 or $500 per month. So that's the cost-saving part of it. All right. So of course, this doesn't come without challenges. There are benefits, there are pros, and then there are cons as well. So what are some challenges of these agents? When we talk about challenges and ethical considerations or concerns, right? So bias and fairness, from the very beginning when it comes to anything tech or programming, there's always been this case of biasness, being biased, being fair. I was working on a project about 2 years ago, and at the end of the project, I asked myself if at some point in time I have introduced my bias into writing this, because it was a very critical point, and I was meant to write a program that decides if someone gets hired or not. And there were a lot of variables or features for me to join together. And then at the end of the day, I say, okay, this person should be hired or this person should be denied. And we all have been there. Sometimes we actually feel we are qualified, but at the end of the day, we get this code email and say, sorry, we can't proceed with you. And I asked myself, somehow, have I been able to introduce or to just be biased about this? So we realize that these algorithms are not biased on their own. They actually reflect human prejudice. And that's true. So the case of being biased and fairness has always been the number one issue when it comes to AI generally. All right. So that's one challenge, and we keep trying to solve this problem. I don't know for how long. Secondly, transparency. All right, decisions made by AI need to be explainable. You know, this issue of interpretability and explainability is also something that has been on the talk, or it has been on the media. If a machine or a system going to say this guy should not be given a loan, or this guy should not be treated, or this guy should not be granted bail. Why? What happened? What are the decision factors that made that AI come to that conclusion? Okay, then number three, we talk about security risks. Okay, AI agents can be exploited if not properly secured. All right, so job displacement. You know, I have to really put this here because there's a whole lot about this job displacement, a whole lot. And it's not even something I can talk about here. So automation may reduce human employment opportunities. And there are two ways to this. I can very much disagree to this same thing I put here. Why? Because, you know, I was reading about the first industrial revolution, second industrial revolution, third, and now we are the fourth industrial revolution. Now, if you're actually taking time to read about what happened during these times, now when we enter the first industrial revolution, the second and the third, a lot of jobs were lost. Let's say when the steam engine was introduced or when it was invented, a lot of people lost their jobs. Then suddenly we stopped using horses, like officially or for commercial purposes. Then we started seeing trains, textile industry, paper industry, glass, a lot of things started coming. More jobs went out of market. And let's say over a period of 10 decades, over a period of a decade rather, like 10 years, right? More jobs were created. And then later, electricity came in, and then much later, computers came in, and then we had the internet boom. Now, if you read about each of this time in history, people were displaced from their jobs. A lot of people, millions of people lost their jobs. For example, the postman lost his job. Why? Because people no longer wanted to write letters. They wanted to send emails. They wanted to chat. They wanted to use Skype. They wanted to use, convenience was there. But what happened at the end of the day? People got a lot of jobs came in form of software development, in form of data, in form of UI UX design, in form of cybersecurity. A lot of jobs were created, right? So it's not like losing per se. Yes, at some point in time, maybe 5, 6, 7 years, a lot of people are going to lose jobs. But then, say at the clock of a decade, more jobs would have been created, at least from what I've read. And I'm very sure same thing is going to happen at this age. Yes, because of course, history repeats itself. So for the fact we are seeing a lot of people, junior developers are not getting jobs because Facebook kind of laid off thousands of workers, and other companies are laying off workers because AI can actually write like the codes that junior developers. Yes, that's true. And people might feel, yeah, this is not worth it. But I think I can even put my money to that, to bet that in the next 7 years or so, there are a lot of jobs will be created. I so much believe so. And then lastly, among the challenges, it's the issue of privacy, okay? Protecting user data collected by AI agent. This is very, very important. Very, very important. User privacy is key. All right. All right. So how do we build or develop AI agents? Okay, what are the steps? For those of us who are tech inclined, even though you are not tech inclined, although there are platforms or apps or websites that actually allow you to build your own agents. Here they are. But let's say you even want to even build from scratch, for example. So to develop an AI agent, there are just a couple of steps, quite straightforward. So first of all, define the objectives, right? What do I want this guy to accomplish at the end of the day? Is it an agent that forecasts? Is it an agent that sends email? Is it an agent that, of course, there will be myriad of agents at the end of the day that does different tasks, all right? So identify the problem the agent would solve, then select the right model. We'll talk about large language models at first. Okay, you can choose specialized ML models from any of these platforms, OpenAI, Google Gemini, DeepSeek, Perplexity, whichever one you prefer, you can choose anyone. We'll talk about the number 3, integrate APIs and tools, connect the agent to data sources and external systems. Now, sometimes one agent might want to interact with another agent to complete a task, right? To complete a task. So number 4, train and fine-tune. Optimize the agent's response in action. Over time, the agent should learn, all right? So that's the fine-tuning we're talking about. So if you're using an off-the-shelf agent, you have to fine-tune them. If you're training from scratch, then that's the first part. All right, then number 5, then deploy and monitor. Of course, those of us who might have deployed or maybe developed one app or the other, you always know that the moment you deploy is not the end. In fact, that's like the second phase of the whole project. You have to keep monitoring your platform, keep checking, has the model degraded? Is there data drift? Is there concept drift? What has happened over time? Okay, then the cycle repeats itself over and over again, all right? So what are the differences between AI agents and traditional software development? So key differences are one, excuse me. So adaptability, right? AI agents are very high and they are very, very adaptable. If you start using it, it adapts easily. But traditional software, it's very, very low. We just say if else, and then it's that way. I know some persons might want to say, yes, some of the apps or websites or e-commerce platforms or wherever, even WhatsApp actually adapts. Yes, it does, because AI has already been integrated into it somehow to understand the things you see over time, right? The people you chat with, and then it places those people as your favorites, right? So then decision-making is very dynamic when it comes to AI agents, but predefined for traditional software. Then learning, it's continuous. But for this guy, it's static here. Number 4, user experience. It's personalized from the very start, all right? Then on this guy, it's generic. That's why you see, if you've used ChatGPT over 3 weeks, if you've not deleted your data, right? And then you open like a new chat entirely and ask the question about you, it definitely will remember something about you. Yes, it definitely will remember something about you, right? So it's personalized. And automation, right? It's end-to-end, right? There's no need for human interference or something. It's end-to-end. But for traditional software, it's actually limited. Okay? So the future of work, you know, there's a lot being said in this regard when we talk about the future of work. Is AI actually coming to displace us, to make us irrelevant or something? To me, I see it more like a partnership than replacement. You know, I was discussing with a couple of friends some months ago, and I was like, just the same way calculators didn't actually stop us from solving maths, right? It helped us to be faster. Same way, AI agents won't displace us totally. It won't, right? There's still room for partnership. So it's just meant to complement, to augment our work, right? So the seismic shifts, AI agents are about to trigger a massive transformation in how we live and work. From healthcare to business, to finance, to software, to agriculture, to education, to about anything. right? So it's going to impact businesses, smarter customer service, more efficient operations, and freeing up time for growth and innovation, all right? So then lastly, added here, those who embrace AI agents now will have a major advantage, while those who don't risk being left behind. Now, I was reading a blog by, I'm trying to remember, was it from TechCrunch or from Tech Cabal? I'm trying to remember, is it too long? TLDR. So the blog, the title was saying AI would not take your job, but ignoring it will take your job. So Andrew will always say something like, AI is not going to take your job, but the people who actually use AI are the ones who's going to take your job. So I'm just trying to buttress on this last point here. I said those who embrace AI, as soon as they can, will have a major advantage or leverage, while those who don't risk being left behind. I'm not saying AI is going to make you dumb or something, but trying to make it, I, as a software engineer, I know back then where I used to like write everything from scratch myself to say, like, let me say 2 years ago, something I would have done like in 2-3 days, I can do it in an hour now. Right, because I have co-pilots there who guides me. It doesn't make me dumb. It doesn't. It makes me faster, by the way. That's how I see it. I can deploy and ship more codes in a week than something I would have done like in a month before. So to me, that's the advantage, all right? So next, so just to round up, AI agents bridge the gap between intelligence and action, right? So they enhance productivity, automate tasks, and improve decision-making. Ethical considerations like fairness, transparency, and security must be addressed. It must be addressed. I know this, we're really far from this at this point, because there's always this issue of, okay, do you think Google is stealing your data? Meta is always facing a lawsuit, and the EU, this trying to ban this platform because we've actually not balanced the issue of fairness, transparency, and data security. We've not actually balanced that yet. So, but I really hope in the future, probably that issue will not be anymore. So lastly, AI agents are rapidly evolving and will play a central role in the future of work. Yeah, it will definitely to play a very, so the age of AI agent is here. So I guess we all are ready. That's more like a rhetorical question. So I guess we all are ready for the change. It's going to change everywhere. It's going to change the way we live, the way we go to work, the way we interact, a lot of things. Myself too, I say at some point I might have an agent who that's going to help me rather to reply some of my messages. And my friend will say, Ben, it's like I'll stop chatting with you. I'll call you rather, So, all right. I don't know if we have questions. I suppose so. So over to you, Neka, and taken from me.
Thank you so much for this presentation. I believe we all got value and all of the teachings, and I hope everyone is too. So if you have questions, there are two options. You either drop your messages on the chat and I'll read it out, or you raise up your hand on mute and we hear what you have to say.
Please, I have questions.
Yes, please go ahead.
That's deep learning and also reinforcement learning in artificial intelligence. So I have that confusion. So I don't know how to clear this.
Sorry, I didn't get that. Can you come
the
again?
Second question. Can you hear me, sir?
Yeah, I can.
Now, in artificial intelligence, is dealing and reinforcement learning. So, sir, I want to know the difference between the reinforcement learning and also the deep learning. And second question is that, like, for example, if you want to train a model like deep learning, so we have to provide data. Understand? So then how can we provide that data set, and how can we train that machine, that deep learning, for a model or to agent to learn and do what maybe the action I asked it to do? That is my question. Thank you very much, sir.
Okay. Thank you, Sanusi. Am I right?
Yes, sir. Yes, sir. I'm
Okay.
Sanusi.
So your first question, I'm talking about the difference between AI, deep learning, and reinforcement learning, right?
Yes, sir.
So AI is the very big umbrella under which all of these fields, right, are under. Now, under AI, we have a whole lot of subfield. You know, it's more like we have medicine, and under medicine, we have a lot of, sometimes some people say they are doctors. And until you go deep, before you know, there are other branches where they specify. Now, under AI, we have stuffs. You see data science, you see data analytics, you see machine learning, you see deep learning, you see reinforcement learning. Now, all of these are subfields under AI. Do you understand? So when you now go under the umbrella, you have machine learning. So now, before now, I can say like 10, 15 years ago, that's when we had stuff like machine learning, using scikit-learn and those shallow algorithms like a super vector machine, random forest, and the likes of them. All right. Now, we now go deeper to what we call deep learning, because there are certain tasks like computer vision and NLP that these ordinary or shallow algorithms couldn't solve properly because they needed a more advanced or more complex model in order to solve those problems. Are you with me, Sanusi? I don't know if he can. Can you guys hear me, please?
Yes.
All right. So that's how deep learning came about into the picture. So you can see now we have AI, and then we have machine learning, and then we have deep learning. Now, under that, we have a subfield. We have different algorithms. We have the now when you come to, I want to go a bit technical now. Please pardon me, other guys. Let me go a bit technical to explain the concept of reinforcement learning, right? Now, when it comes to types of machine learning, we have supervised and non-supervised, and then we have reinforcement learning. Although some people will say we have semi-supervised. So supervised simply means you're giving it data and more like X and Y, right? Giving it answers and the labels or the answers. Then unsupervised simply means you're giving it data and allowing it to figure out the answers itself. The reinforcement learning simply means learning by figuring it out yourself. For example, now, if I lock you in a room, Sanusi, and I kind of close your eye, I blindfold you and ask you to go out of that room and use your hand to find the door. Maybe after 5 minutes, you're able to figure out where the door is. Over time, you can open that door yourself, just like in our house. You can get into your house in the middle of the night and still on your switch and still flip your switch to on the light, right? That's because you've learned over time. So that's what reinforcement learning does. So let's assume you don't know where the door is and you went to like stop over your bed or hit your leg on the table. You've learned that next time you're not supposed to go to your left, you're supposed to go to your right. So that's what reinforcement learning is. So it's different branches. Well, at the end of the day, we are still trying to solve the same problem. I don't know if you understand. We are still trying to solve the same problem, but using different methods to achieve a single goal. So that's where you have the shallow machine learning. Then when you go deep, you have the deep learning, and then under deep learning, you have NLP, convolutional neural network. Now, NLP is where you have all of these speech to text, large language. They are all under all of those, the NLP and all. Then when you talk about computer vision and all, that's where you talk about a convolutional neural network. I don't know if you understand a bit. I know I don't want to go too technical, so we don't spend the whole time. Did you get that, Sanusi?
Yes, sir. Yes, sir. Remain the second question, sir.
Yeah. So the second one, how do we train these agents? Am I right?
Yes, sir. Like
Now,
for example, the data set.
Yeah, so there are
Like,
two
for
ways, for
example, the
example.
data, how can we,
Okay.
for example, now, for example, if you want to teach a model, so we have to provide the data set. So
Yes.
that is why maybe data analysis or data science come along, for example.
Yeah.
So now, how can we get the data and how can we train the model to learn if we get the data set?
Okay. First
Like
of
the
all,
agent.
let me answer your first question of saying how do we get the data? The data could be proprietary, it could be open source, it could be data you bought, or whichever way you gather that data. It doesn't matter. Well, it matters to you. So the data can be from anywhere. If you're working for a company, it could be your own data. Like I work for a company, we have a database of thousands of users, right? So I can pass that data through the pipeline to be fed into the algorithm, right? And that's where the data science and data analysis guy, or wherever they come into. Now you see, we have different people working together. You're not just the only person working, the ML guy or wherever. You're not just the person working. You have the data analyst and the data scientist working together to get the data in shape and then passing it on to you who builds the model. And then before there's another guy who deploys the model. Now that's how to get the data, either proprietary or data that you get from anywhere. Then how you build a model. If you are someone who is into programming, good and fine, you have 100% flexibility to code your own model from scratch using maybe PyTorch or TensorFlow or whichever one, right? You build your model from scratch. Now, of course, most times some of us might not want to reinvent the wheel. We might want to say, okay, let me use off-the-shelf model and just fine-tune, which is what I do most times. Yes, I learned all of those maths and statistics and how to build from scratch. But these days, I hardly build from scratch because it's to me, it will take more of my time. I will just use a pre-trained model, right, and fine-tune it and feed my data into it. There's more if I go into how those data are being fed. Of course, you have to split the data into training and testing and validation, right? And then you convert those data. Let me use the word, a very simple term, convert that data into numbers. That's what the data analysts do. Of course, you convert either a picture, video, audio, whichever way. Computers don't understand them in that format. Computers understand that in number format. So whichever format you get that data, in text, in audio, in video, in picture, in image format rather, you convert that into number and split and feed that array or tensor or whatever into the model, right? And then it runs a particular number of times, which we call epoch. And then, of course, it learns. So in the simple way, let me just give you a practical example of that. So you take a multiplication table or maybe, a multiplication table and give to a child and say, I want you to recite 2 times 1 to 5 times 1, 7 times. So if that child is very, very smart, after reading that 7 times, the child will be able to memorize. Am I right? The child will be able to memorize. And when you say what is 2 times 5, the child can tell you that 2 times 5 is what? Is 10, right? So that's the same thing this model they do. After training a couple of times, they already know the patterns they've seen. We call them patterns. They study the patterns they see in that data. And when you ask a question, it will be able to answer you. I don't know if I was able to answer your question. Don't worry, we'll have a more technical section where we are going to build a model. All right. So I don't know if I answered your question, Sanusi.
Yes, sir. Thank you very much, sir.
Yeah.
Yes, sir.
So do we have any other question? Any other question, guys?
Okay. I think we have a message
Okay.
from. Thank you for an amazing presentation. I suppose if you registered for the webinar, you will get a copy. Also, someone is asking, how do we create synthesized data sets when we don't have them available in the public domain. You want to answer that, Benjamin?
Okay,
Hello,
you want to say something? You
Benjamin.
can go on if you want to say something there.
Someone is asking how.
Okay.
Okay.
Okay. Yeah. Sorry, the event was ending, but I had to ask this last question. I heard when you said that we can use if we don't have the data ourselves. So, for example, I am an entrepreneur and I am trying to build an AI tool, and I do not have any pre data with myself because I did not run any company before. But now that I want to create this AI tool, I need some data set to train the model that I will be building. So, will I need to create synthesized data sets for it? I have been reading about it that you have to uh, create fake data sets which would resonate with how you want your results to be. So, I just need some understanding on this, if you may please.
Okay. All right. Thank you, Meg. Um, there are many ways we can create synthesized data. Um, there are many ways depending on the task you are solving, right? And sometimes we call that data augmentation. If you already have a little amount of data, and which might not be enough, you might want to augment your data, right? If it's not balanced. So you are saying, let's assume you don't have data at all, right? And you want to train your model to solve a particular task. Now, there are a lot of tools we can actually use to accomplish that. Of course, you wouldn't want to do this yourself. Say you want to maybe create, something just came in now, and I was trying to though I'll talk about that after I answer your question about synthesized data. Again, so now you can use specialized tools. You've heard about GANs, generative adversarial networks, right? Or variational autoencoders, right? Now, these methods, right, or these models, giving some data points or giving some samples, even if it's one, I know you already have an idea of the kind of data you expect to have. If you're trying to create data of maybe a health record or something, you should have maybe one or two, even if it's something that's made up from your head. And when you pass through this network and ask to say, okay, I want you to create data that looks like this. I've done that before using some of these platforms we have. When I know I don't have the time to create like 500 data points, and I say, okay, hey guy, create something 500 more points for me, right? And in less than 5 to 10 seconds, I already have all of that data. So you can even use ChatGPT. I know, so you can use ChatGPT for that to create synthesized data. And you can also build your own GANs, like I said, generative adversarial network, or maybe your own autoencoders. And like I said, you can use data augmentation to transfer. Now, data augmentation comes, of course, when you have a little bit of sample. So let's say you have an image of a cat, just a single image, and you want to get more images, like maybe 1,000 more images. There are many ways you can create fake data. Yeah, fake ones, because it's not the original one. You change the lighting, you change the position, you crop some, you flip some, you do so many things. And at the end of the day, you have like many more, same image, but in different variations. So in other words, you've created a synthesized data. I don't know if you understand. So, but if you don't even have data at all from the very beginning, yes, I wouldn't even want you to go from scratch and maybe write an autoencoder or an adversarial network to do that for you. You can actually use any of this platform to generate synthesized data for you. So now what I was going to talk about, and when we when I was talking about synthesized data, I wouldn't really advise someone to use synthesized data from the very scratch. So even if you're going to use it, it should be for like a period of time. Then later, when your platform picks skills, and then you can fall back to using real data, because synthesized data is not really representative of the real value. Yes, it's not really representative. It can be imbalanced, it can be biased. So many things could actually go wrong there. So if I
Yeah,
told
yeah,
you to use a synthesized data, maybe much later on you can fall back to using real data. Yes, for practice or maybe for a start, it's fine. Okay, it's fine, but I sometimes have reservations for using synthesized data 100%. But if you're using it to augment your already collected data, I do that a lot, but 100%, I don't use synthesized data for my work. I don't. So I don't know if I
I
answered your
see.
question,
I
right?
see. Thank you. Yeah, yeah, it makes sense, but like to train a model, you need at least like 50 million plus values. So even if I get a few real values, it would be 100 plus or 1000 plus, which would not be enough to just train the model. But what you said makes sense. I will read more about it, and I have joined, like, I have signed up a couple of other Pi and AI events. Probably I'll get back to you on this. Definitely, I'll have some more follow up questions once I read more on this.
Okay, yeah. Before I answer the next question here from Grace, you talked about having 15 million. I wouldn't know the kind of network you're trying to build. I wouldn't know, but there's this term or this paradigm that has been going on since the end of 2023, where we talk about data-centric AI. So we are kind of moving away from model-centric AI to data-centric AI, whereby you don't really have to have millions of data points to train a model, right? As much as your data is clean,
Okay.
you can have as few as 1,000, 100, and train your model very, very well. Maybe you tune your hyperparameters and get the right epoch, get the right optimization and what have you. And even with a few thousand, yeah, hello? Okay, so even with a few thousand, you can actually
I
achieve
think
a
there's some
good amount.
distortion.
Yeah, I think you can achieve a good amount of accuracy. So even if for a start you don't have the millions, I said so because I've actually trained with just 50 data points. Yes, I've trained a deep learning model with just 50 data points for a start. And then the model learned over time. The more people we are using, I was getting more data and retraining. So you don't have to wait to get millions of it. Okay?
Okay.
And
Okay.
and
I'll
then
read more about this model centric.
okay, I think
Sir,
I'll get in touch. I'll get in touch. I
hello?
think I'll get in touch, then we can talk further on that if that's fine by you.
Sir, hello?
Yeah, so Grace, let me go
Sir,
back to the question from Grace. Can you guys hear me?
Yes, we can hear you.
Okay, so Grace said, please, I'm curious, in cases where it has to deal with customer service, Rose, how do you accurately train this model to be able to respond to clients' need correctly? Is it really possible to capture all possible questions these clients will be needing to answer? Yes, it's possible. It's very possible. Now, I'll give you an example. If you've called, let me use an example from from Nigeria now. If you've called MTN customer care before, or maybe Glo or any other customer care, as a matter of fact, sometimes they will tell you to hold on for a second or so. What are they trying to do? They are maybe punching or tapping on their computer to try to check through their database of frequently asked questions to get your answer. Now, that's one example. Now, a few weeks ago, I was working on a project with a couple of engineers, and we wanted to integrate a chatbot, a large language model, let me say an agent, onto the platform. It's an e-commerce platform, so that customers don't have to, maybe you don't know what you actually want, or maybe you have a budget. You don't have to search and check 50,000 or, sorry, not 50,000. You don't have to check maybe 10 pages before you see the product you want. You can just you can just ask the chatbot or the agent and say, okay, I live in Abuja and I want to buy a Nike, a black Nike, maybe jogging shoe, and I have a budget of say 25K, and I need it. I stay around maybe Gariki, for example. Just give you this couple of questions, this couple of commands, right? And this agent is going to go through the database. Of course, we connected the agent has access to the database of catalog of products, thousands of products, of course. Then just within split seconds, it goes through that. And those are the things we discussed, right? It first of all understands what you asked. Then it goes through the available data. Now I'm trying to give you a background of this customer service, right? So definitely there will be a database of frequently asked questions, of possible questions. Then when this AI, this agent, finds a similar question that is close to what you asked, maybe regarding payment, regarding return policy, regarding your open or closing hours, regarding maybe promo, regarding just about anything, it will be able to answer. Now, for a start, I might not say 100%, which is what you said. Is it really possible to capture all possible questions these clients will be needing? For a start, it might not be, but this agent is meant to learn over time. Do you understand? So if there's any question it's not been able to answer, it's meant to learn. Then that's where your feedback comes in and say, okay, this question was not actually answered properly. I don't know if I'm really answering your question. So even the humans themselves, if you employ a customer service personnel from the start, you have to coach that person. If I don't know if you've actually worked with the customer service, you have to actually coach the person and say, okay, read this manual for the next 1 week. These are the questions our customers, this is what we have. We have this hair cream, we have this shampoo, we have this thread, we have this cloth, we have this shoe, this is how much we sell it. If this is finished, we are going to restock it in 2 weeks' time. That's you train a human agent. So same thing happens to the AI agents. You actually give it data, the database, an Excel sheet, whatever. And yes, so I don't know if I answered your question, Grace.
Yes. Thank you so much.
All right. So I don't know if we have any other question before we.
Sorry, do we have any other questions?
Yes, sir. No question, no question.
Please go ahead.
Please, sir, I'm getting data. For example, I'm from Sokoto State, Nigeria.
Okay.
So where we have security, bandit, and other something like that, and Sokoto and Zamfara State. So I am collecting data right now from people to create a model that will maybe to come out with the solution that will help both the security personnel and also affected members in Sokoto and Zamfara. So, for example, now, how many data do I expect to get to train the model, to get the analysis of the model, sir, for your own advisor? Thank you very much. I don't know if you understand what I'm trying to say.
Yeah, I very much understand you.
Yeah, I very much understand you. Yes, sir.
And
So
I can say there's no limit
I can say there's no limit to.
I don't know.
I don't know.
What's the echoing?
What's the echoing?
Can you guys hear me? Okay.
Yes,
Can you guys hear me?
we can hear you, boys. Yes.
Yes, we can hear you.
I don't know. Someone's Salisu, can you mute? Sanusi,
I don't
can
know.
you mute?
Someone's can you mute? Sanusi, can you mute?
Oh, sorry.
All right. So as I was saying, there is no criteria or benchmark where we say this is the amount of data you must have. But at least you should have a couple of tens, maybe from 50 upwards. Yeah, I know I was talking about data-centric AI. That does not mean you just say you're collecting one data point and training your model. That wouldn't work. Just like you tell a child to go through the multiplication table just once, the child won't actually know anything. Okay, it has to see a lot of apples, a lot of aeroplanes, a lot of footballs to know that this is what aeroplane looks like. Do you understand? So I can say, since you're the person collecting the data yourself, I don't know how difficult it is for you. You can collect as little as, say, maybe 100 samples or something to thousands. There's no limit. There's no limit. But for a minimum, I can say you can start from 50. Okay. And if you're able to build your architecture, your model architecture very, very well, I believe, yeah, the model is going to be able to learn from even as small as that. I don't know if I answered your question, Samson.
Okay, I believe you answered her question. So, do you have any other questions?
So Meg,
I
you can reach me out on this email. Although I have your email too, but so I don't get to forget, you can reach me out on this email so we can talk further. All right. Thank you.
Okay, in the absence of any other question, I want to presume we have officially come to the end of the webinar. Thank you so much, Benjamin, for the elaborate and well-detailed answers you provided to every question. I also want to thank you for the well-detailed presentation you provided us. I am sure everyone got value from this section. So thank you all for attending and making it this with us, even though we exceeded our budgeted time of an hour, but you all stayed true to the end. So we want to assure you that more webinars are coming your way. So you have to follow us on all our social medias, on LinkedIn and on X at Pi and AI Abuja, so that you can be up to date with every information that we have. So don't forget to go to the LinkedIn and the X to follow us on this page, on our page, Pi and AI and Abuja, and we will keep you posted with upcoming webinars. So thank you so much for attending. Do enjoy the rest of your day or evening, depending on your time zone. It was nice having you all on the